charged. Whee. Okay, some people just came to class. Could you? Okay, and anybody else see? Chan and Marcos and Raul. Anybody else want to get on the start logging time right now? Go ahead, raise your hand. See, Jake. Anybody else? Today. Yes, and William? All right, sorry I got off to a slow start. We'll try again. So here's the slide that Mr. Zilke told me he left off on. There's my email address, john.johnson@reedleycollege.edu. There's my telephone extension. Does anybody need the phone number to Reedley College? My office is right on the other side of this wall. You probably have never seen me. I think I've subbed for Mr. Asman on enough occasions. I think you've seen me a couple of times. All right, so I'm here to give you all the answers to the test. Is that the way it works here? Okay, I have one yes and a nod. Everybody else, they just want to become an aircraft mechanic. They don't really care about the answers to the test. Unfortunately for you, I have not read the tests. So the best I can do is make sure that I emphasize all the things that I think are important about being an aircraft mechanic. The best thing you can do is write down everything that's important and maybe write down a few things that you don't think are important but are on the screen. Any questions? As I said earlier, before I started at the beginning, before I started recording, I'm planning on being here today and probably tomorrow for Mr. Zilke's lecture. Oh, man, I'm just as disorganized as I can be today. I'm teaching high school ROP students, and we've been out of lecture for 2 weeks, so I actually haven't even given a lecture for a couple of weeks. I can barely remember what it's like. So let's see. I don't think I can go random. How about eeny, meeny, miny, mo, Dominic? Sorry, you're in the middle row, and you're not really Mo, but you came up there. So tell me, on a 12-volt battery, lead-acid battery, how many volts, if you measured the battery, if nothing's connected to it, and you measured the voltage, and it was a brand new battery, it was fully charged, and it's 80 degrees Fahrenheit. Like working on somebody's airplane. Say that again? Yeah, it's a 12-volt system. The battery is fully charged. It's a brand new battery. And the temperature of the battery is 80 degrees Fahrenheit. What's the voltage that you would expect to get on that battery if you measure the voltage, but nothing is connected to the battery? It would be a little, yeah, when I say 12-volt system, we're talking 12 to 14 volts, but that's just the name of the system. That doesn't really give you the exact voltage of the battery, and it doesn't tell you the exact voltage when the alternator. So this is what I'm asking for. What's the exact? It's going to vary a little bit. No, closer to 14 would be if the alternator's working. Let's see, the gentleman behind Dominic, your name is? Leo, what's up, Leo? Can I say what's that? That's so 90s, right? Remember the Budweiser commercials? What's that? Okay, a couple of you remember that. A lot, everybody, the guy on a telephone. Okay, if you haven't seen it, don't worry about it. So, you want to give it a try? 12.6? Why did you guess 12.6 and be correct, Leo? Because you just remembered. Okay, so here's a couple of things that you need to know. 12 versus 14 volt system. So what I'm saying is you could call it a 12 volt system, you could call it a 14 volt system, but it's the same thing. And you're going, but Mr. Johnson, why do they have two different voltages? Why confuse me? I just want to be a simple mechanic. and fix stuff with tools and spit and stuff like that? Not even a grin. Okay, Eric was grinning. I saw you grinning when I said spit, Eric. Thank you. Okay, it's because in this kind of a system, most of the time on these airplanes, this is a lead acid battery. So we're talking about a lead acid battery. It's going to be 12.6 volts. And that's if it's a brand new battery, it's fully charged, and nothing's hooked up to it. And be careful, if you charged it up and then took the charger off of it and immediately went to measure it, it's going to be higher than that. So we're talking about something that's been charged and it's been sitting around for an hour or two, a day or two since you took the charger off of it. Does anybody, let's see, we'll go down the row. Jose, why 12.6 volts? Well, we're not charging it, but why isn't it 17? Or why isn't it 7? Do you know why it's 12.6? Because of how many cells there are. Marcos, how many volts, how many cells are in a 12.6 volt battery that's a lead acid battery? How many cells? How many places for you to put water and acid in? I know this is tough if you've never done it. Try again. It's not 12. Have you ever done this before? You ever put water in a lead acid battery like in a car? Oh man, well you're never going to know. So Jason, you've put water in a lead acid battery in a car. Surely, you've done that. 6 cells. Yeah, just to be clear, when I say surely you've done that, the proper response is, yes, Mr. Johnson, I've done that, and please stop calling me Shirley. But I'll accept that answer. Yeah, there are 6 cells, and therefore, James, how many volts does each cell of a lead acid battery produce when it's fully charged? I know this is tough. Divide 12.6 by 6. Huh? 2 point? What? 2.1, yeah. The reason this battery is 12.6 is because there's 6 cells in it, and in a lead acid battery, each cell produces 2.1 volts. This is going to be tough. Go ahead, Brian. I know you can answer this one. On a typical drugstore, Kmart, Walmart battery that goes in a flashlight, how many volts is it? Have you ever put a battery in a flashlight? You haven't. Let's see. Behind Brian, I'm sorry, I forgot your name already. Albert, have you ever put a battery in a flashlight? Okay, so how many volts to that one battery? Okay, all right, we're going to start up on this end again. Raul, flashlight battery, the kind you buy at the store. Just a regular old battery, alkaline, Duracell. How many volts? Man, well, it's a good thing you came to class today. Does anybody know? 1.5, all right. So you can take a voltmeter to a household battery, and if it says 1.3 or 1.4 or higher, it's probably okay. If it says 1.5 or 1, you're going sweet. Okay, you just learned something you can use that the rest of your life. When you're a grandparent, you can show your grandkids. If you don't have any kids or they don't have any kids, you can just show the neighbor kids. Yeah, don't laugh too hard, Rodney. Don't laugh too hard. All right, so the reason that's 12.6 is because lead acid batteries, 2.1 volts per cell. And if we multiply that times 6 cells, we get 12.6. All right, so now we know what the voltage is. If it's a brand new lead acid battery, it's fully charged, it's at 80 degrees Fahrenheit, and we haven't had it on the charger for at least an hour or so. Now the question becomes, let's see, how far did I get down here? I got to Raul. I didn't ask you a question, did I, Danny? All right, well, you're up next. So, Danny, you've got a Cessna 150. It's old school, 1965. It's got a 12.6 volt lead acid battery in it. How much voltage is the alternator when you turn it on? You start up the engine. Of course, that thing's so old, it doesn't have an alternator, it has a generator, but it's still the same number. When you start the engine up and you turn on the generator switch or the alternator switch, and if you had a voltmeter hooked up to the system, what would the volt say? Before you turned anything on, the volt said 12.6. Now you turn the alternator or generator on and it says about 14. Sweet. Now I would have said 13 and a half or 14, but Mr. Zilke's notes say 14. So that is the battery. is 12.6, but the alternator or generator is about 14. Wow, check it out. 14, 12. So does anybody have any questions why you could call this a 12 volt system, or you could also call it a 14 volt system and you'd still be about right? Because if you have any questions, I can harass you like I've harassed other students. Now, other small aircraft, instead of having a 12/14 volt system, they have a 24 or a 28 volt system. So who's behind Danny Chan? If we have a lead acid battery in this 24/28 volt system, how many cells times 2.1 volts? How many cells do you think are in that lead acid battery? 12 cells. So really tough. Get out your calculator. What's 12 times 2.1? 25.2. So what do you think the battery in this 24/28 volt system, if it's a brand new battery, it's lead acid, it's fully charged, and it's at 80 degrees Fahrenheit, and we took it off the charger at least an hour ago, the voltage, if nothing's hooked up to it, the voltmeter's going to read 25.2 volts. That's for the battery. So I'm sorry, behind Chan, your name, sir, is? Marco. Can I say it like that? I grew up in the United States, so I can't roll my R's very well, but I'm working on it. Does anybody else have trouble rolling their R's? I'm the only one. Okay, all right. So, Marco, if we want to charge this battery, can we hook it up to a 23 volt alternator and expect it to? It won't charge. How high a voltage do you think we probably ought to put on it to charge it? 28. Score. You were looking at the board, weren't you? That's exactly right. Very good. 24 volts is the alternator or the generator. You can hear something you really need to understand as an aircraft mechanic. Is it okay if I tell you something really important? All right. If you want to charge a battery, you have to charge it with a voltage that's about 10% higher than voltage. You don't have to 10%. You just really need to remember it's got to be higher. If we've got a 12.6 volt battery, we need to charge it at a volt or two higher than that. A volt higher than 12.6. A volt would be 13.6, would be 14.6, between 14.6 and 14. For a 25.2 volt lead acid battery, we need to charge it about a little bit higher, about 2.5 volts higher. Guess what that is? 27 or 28. So, let's see. Valentino, the owner of this little tiny airplane, it's a 1965 Cessna 150 school. It's got the 12 volt system in it. And let's say you don't hit yourself with the propeller while the engine is spinning, which is really important. Anybody ever been hit with the propeller while the engine was spinning? If I raised my hand, you would think that that explains a lot about me, wouldn't you? Okay, thanks, Dominic. You're laughing so loud your head is shaking. All right, okay, all right. So I appreciate that very much. So you don't have like a twitch or anything that makes your head shake? Okay, so it was just that joke. Thanks. So Valentino, it's this old school airplane. You don't get hit in the head with the propeller. It's got a 12.6 volt lead acid battery. If we start the engine and the alternator or the generator is turned on and we put a voltmeter into the system, let's say we hooked it up underneath the dashboard, underneath the instrument panel inside, so it's really hard to get hit by the propeller when you're inside the airplane and the doors are shut. Okay, so we hook the voltmeter up inside and we measure the voltage of the system. If the generator is working, how many volts would we read approximately? It's a 12/14 volt system. If the battery's hooked up, but we also start the engine and turn on the alternator, so the alternator charges, well, that's the voltage of the battery, but what's the voltage of the alternator or generator going to be if it's running? 14. All right, so now we know. So this is why we need to know it. If the alternator's working, I can hook the voltmeter up and it ought to read around 14, and this works for cars. Hang it. Because you need the alternator to be able to push electrons into the battery, and for the alternator to push electrons into the battery and charge the battery back up, it has to be a little higher voltage than what the battery is. So if the battery's 12.6, then we need the alternator to be about 14. The alternator is going to charge the battery. Well, the power comes to the alternator from the engine. The alternator takes rotating energy from the engine and turns it into electrical energy. Question? That's an excellent question. The question is, even under load, is the alternator able to keep up that 14 volts? And generally, 99.9% of the time, the answer is yes. You got to understand the alternator is designed to put out enough electrical power that after you start the engine and you turn on the alternator or the generator switch, it'll put out enough power to charge the battery and to run everything else on the airplane. And when I say everything else, I'm not saying you literally turn on every single thing in the airplane, but generally the way it's set up is that if the battery's fully charged, the alternator or the generator, if you turn, it ought to be able to, let's see if I can remember the right numbers. If you turn everything on the airplane, the percent of what the alternator put out. So that would still leave 20% of the alternator output to charge the battery. So in flight, after the battery's charged, you could turn everything on in the airplane, and the alternator would only be working at 80% of its rated capacity. So if the alternator could put out 100 amps, so let's say you turn on everything in the airplane and it takes 80 amps, then 90, almost for sure the alternator is going to put out at least 100 amps. Am I answering your question okay? If it couldn't put out enough, the voltage would be a little less than 14 volts. All right, it's because something's wrong with your charging system. Yeah, the nice thing about alternators, and you can write this down because it's really important, there's a big difference between alternators and generators. And when I say generators are found on old school airplanes, that's true, but they're also found on that helicopter and that helicopter and that helicopter. And do we have a business jet in here? There's no business jets. Smaller business jets have generators. If it's a turbine engine, anybody in here, well, turbines was last semester, right? In any case, if it's got a turbine engine, a jet engine, and it's a small one, it probably has a 28-volt generator on it. But jet engines run so fast, it'll spin that generator really fast, and you won't have a voltage problem. If you come up to a stoplight in your car at night, and you take your foot off the gas, and you finally come up to the stop, and you notice the lights are going dim, either the voltage regulator isn't telling the alternator to put out enough amps, or the alternator isn't putting out enough amps because something's wrong with it. Pardon me? Something is crap? Well, okay, either the regulator, something's wrong with the regulator, something with the alternator, could be something wrong with the wiring between all of it, which is something we as aircraft mechanics need to pay attention to. It's not always the component, it might be the connections. And with electricity, if you have a hydraulic leak and red hydraulic fluid spills out all over the ramp, is it pretty easy to, aha, hydraulic fluid is not getting where it's supposed to? It's pretty easy to say, aha. Okay, but if it's electricity, does electricity fall out across the ground and go, wow, look at all those electrons. I must have a leak. The electrons aren't doing what they're supposed to. No, so that's one of the things about electricity that makes it harder is that you can't, they're not doing what they're supposed to do. So mechanics got to pay attention to the fact that it may be that component, it might be that component, but it might also be the wires and the connections. Anybody ever fiddle with a car battery? You notice the connections at the battery because it's a lead acid battery. Some of that acid, sulfuric acid, that's not the kind that's in your stomach. The kind that's in your stomach is hydrochloric acid. Very good. All right, sulfuric acid is very bad for you. If you get it in your eyes, it can scar your eye. That's why you always wear splash goggles when you're working around these batteries. You might also decide to wear gloves, but if you get it on your hands, say, I got it on my hands, and I go wash it off in 30 seconds or a minute, you're probably not going to notice it. If you do notice it, it'll feel like a really bad sunburn. And of course, it might scar your skin, but hey, we're aircraft mechanics and we like scars because we can show them off in bars and stuff. And yeah, I got this when I was working on the 747. It's done that in a bar? Okay, all right, pretty much. Okay, or some other adult beverage available location. Okay, I guess that's the only time when I show off my scars is when I've been drinking adult beverages. So can anybody name an example? Well, I'll name an example of an adult beverage. Prune juice. Because kids will not drink prune juice, so only adults drink. Same thing with grapefruit juice. Grapefruit juice. Are you over 18? Okay. Okay, well you were an advanced youngster if you liked grapefruit juice before you turned 18. All right, so I've spent a lot of time on this, which I'm very happy to have done. Does anybody think the last 20 minutes was worth it? So let's pick up where we left off. I'm sorry, I forgot your name already. Bobby? Okay, Bobby. So we go out to a turbine engine powered helicopter. Let's say it's that white one up there on the wall. That's a Bell product. I can't tell if it's got one engine or two in it. It's got generators on it, and it's a newer one. So it's almost for sure it's got a 24 or 24/28 volt system. Okay, if it had a lead acid battery, and I go out to the aircraft and it's been sitting for an hour and nothing is turned on, and I open up the cowling or wherever the battery is and I put my voltmeter across the battery. If it's a lead acid battery, what's it going to read?
It should read,
if everything was working correctly. The engine's off, it's been sitting for 2 hours, so they'll point. All right, and of course I could have said it's 85 degrees, and you put the battery in about a week ago, so it's a brand new battery. Okay, so your names are? One more time? Enrique? All right, Enrique. So the pilot comes out. Now, forget the pilot. The other aircraft mechanic, you don't need pilots to start up helicopters. You do need pilots to get off the ground. Well, actually, you can get off the ground without a pilot certificate. It's just a really bad idea. So has anybody ever flown a helicopter with no flying lessons before? With no flying lessons before? Okay, all right. So you need to watch this movie. It's called Hot Rock. It's about 40 years old. It's got Robert Redford in it when he was in his late 20s. You're like... In any case, the movie's called Hot Rock, and in it, this group of thieves, they're violating federal, state, and municipal statutes, and they steal a diamond. I'm not giving away too much here, because that's the name of the movie, Hot Rock. One of the members of the gang steals a helicopter, and he's never flown a helicopter before in his life. He just read how to do it. It's a rather interesting scene. Just to be really, really clear, in real life, he would have crashed and died. But it's the movies, so he didn't crash and die. But let's say you go out there and you're not going to fly today, okay? All right. And you and Jonah are going to start the helicopter. Jonah starts the helicopter up. And then he gets the engine running, and then he turns on the generator. You now go measure the voltage of the electrical system. The generator's running. How many volts will you see if the generator's working correctly? 28! If I had a gold star, Enrique, I would give you a gold star. If you got a piece of paper, I could put a little star on it. Okay, all right. All right, I'm going to cover some lecture that Mr. Zilke told me to cover. So I'm going to talk about servicing batteries. When I say servicing, that really means you're taking care of them so they keep working correctly. Or you do preventive maintenance. You do stuff to make sure that little thing that needs to be fixed so it'll keep working for a long time. So just like I talked about a little while ago on cars, a big problem with lead acid batteries even on aircraft is the corrosion at the battery cables, where the battery cables connect into the lead acid battery. And there's an urban myth out there about pouring Coca-Cola off it. It's actually not an urban myth. It actually works. But that is not an aircraft approved fix for corrosion. What you really need to do if it's that corroded is take the battery leads off, use baking soda and water. Baking soda is a base or an alkaline, and it's the opposite of acid. So the alkaline in the baking soda neutralizes the battery acid. But here's the key. If you're ever cleaning a lead acid battery with baking soda, do not let any of the baking soda water get into the inside of the battery, because that'll ruin it. So if you've got the tops off and you decide, okay, now I'm going to clean it, if baking soda water gets inside, you're ruining the battery.
I was watching the video saying on the car saying that using baking soda water to clean out the system.
Yes.
Filled up with distilled water and then another component. I can't remember.
Sulfuric acid.
Sulfuric acid.
Yeah, generally speaking, you're going to buy the water with sulfuric acid already mixed.
And that's how they refurbish certain batteries.
I have not read up on how to refurbish a battery. As aircraft mechanics, we do not refurbish lead acid batteries. We install them. If you get one brand new, it'll ship with the lead acid battery, and the acid with water is pre-mixed and it's in a separate container. You got to put it in the battery and you let it sit for half an hour and the bubbles come out. Then you pour in a little more, and then you charge it up nicely, and then you check it again, maybe charge it some more, maybe put in some more of this water with sulfuric acid in it, or electrolyte is the technical term for it. But we never take these batteries are not designed to be taken apart. These batteries are not, just like in a car, if you take it apart, you're breaking the plastic. Same thing for lead acid batteries on airplanes. If you take it apart to fiddle with the inside, then you're breaking it, and you will never find a maintenance manual that tells you how to do that. You can't do it. All right, so if you're going to inspect the battery, one of the things you're going to do is look at the terminals, and if it's corroded, then you're going to disconnect everything. You're going to clean it off with a solution of water and baking soda, and then you're going to rinse it so there's no baking soda left. You're going to need to dry it, and I just use paper towels. And then I'll come back in 5 or 10 minutes when the water is dry. And then, if you want to prevent the corrosion, you can put something on the battery connectors so that corrosion can't get to, so the acid can't get to the connections. And one thing, it's called dielectric grease. It's really just silicone grease. But dielectric means no electricity will go through it. No electricity will go through it. So you rub it on the metal lead that sticks out of the battery, and you rub it on the battery cable, and you cover it. It can be really, really thin. Being thick doesn't do any good. And then you put it all together, and when you tighten down the connection, the metal hits metal, and the electricity will go through the metal. So you don't have to go, oh, well, if I put this grease on it, then electricity won't move. That's a good thought. I appreciate your logic. But you'll end up squishing it down, and metal will touch metal. If you're in a car and you don't have dielectric grease, pull out the stick and put some oil on your hands and rub oil around it. That actually works pretty good. Really what you're doing is you're keeping the sulfuric acid of the battery from getting onto the connections. Because as long as the acid can't get to the connections, then corrosion can't happen. And that corrosion will prevent electricity from moving through the connection. Some, 10, 20, 30% of the time if somebody's car won't start, it's not because the battery's no good, or it's not because the alternator hasn't been charging it. It's because the connections at the battery are messed up. So literally, in a pinch, you can go out there and unloosen them on the battery and twist them a couple of times and make the metal hit and tighten them back up. And about 20% of the time, that'll fix it and the car will run. But it's going to go bad here pretty soon, so you really need to take apart, clean it. All right, so we got baking soda and water. Hey, wow, it's like I read this before. Don't let the solution get into the battery, rinse it off. On airplanes, see, on cars, if you look at a car battery, most of the time the battery's just sitting there all by itself under the hood, and it's not in a box. It's because the car manufacturers know the box is just going to rust and corrode from the sulfuric acid anyway, so why put it in a box? So they just clamp it down and stop worrying about it. But on aircraft, we have this thing. We really don't want the fumes getting into the cabin and having people breathe it. So generally on airplanes and helicopters, there'll be a battery box with some kind of a tube, usually at the bottom, that goes outside of the aircraft. So if there's any gases in there, they leave the aircraft and nobody inside can breathe it. That box, made out of aluminum, aluminum will corrode really, really well with sulfuric acid. Easy. So one of the things you do when you're doing an inspection on an aircraft, or if you pull the battery to work on the battery, you need to look in the box and see how bad the corrosion is. And at some point you say, well, that corrosion is bad enough, I need to do something about it. If it's very light corrosion, you can take a metal brush, like a brass brush, and scrub the corrosion off and clean it, and then paint it with corrosion resistant paint. There's literally, it's called battery box paint. It's literally called battery box paint, and it's black, and you paint it. Dun, 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 dun. You'll notice when it's talking about if you put water in the battery, it used distilled or demineralized water. Question? You just stretch it. Go ahead. Okay, what does the water and baking soda do? Okay, there's acid and there's alkaline. So acid is something that like eats things away and dissolves it. Alkaline is, I'm trying to explain what's the opposite of acid. Acid is more like a burn, but they're opposite to each other. So, oh, I know. Have you ever had an Alka-Seltzer? Do you know what an Alka-Seltzer is? Okay, have you ever had heartburn and you ate some Tums or some Rolaids? Okay, all right. In your stomach is acid, and sometimes that acid comes up your throat, and you can feel it in your throat, and it hurts. Tums or Rolaids is alkaline, like chalk. So you chew it up and swallow it, and it's the opposite of acid. When acid and alkaline get together, they neutralize each other, so it's not acid and it's not alkaline anymore. Right halfway between acid and alkaline, right in the middle, is water. Water's not acid, water's not alkaline. Say that again? Well, if you start puking, you can probably taste it on your tongue. Is that what you're talking about? Yeah, okay. That's when it's time to eat. And that's acid. You need to eat some, that's what Tums and Rolaids are made of. Water is neutral. Water is right in the middle between acid and alkaline. So the acid, if a little bit of acid gets out of the battery, it'll start corroding any metal parts, including the connections. So to stop that corrosion, we have to neutralize the acid. So we take some alkaline, which is baking soda and water, just like the Tums or the Rolaids, and we mix the baking soda and water, and we put a brush in it, and we brush the connections, and that cleans off all the corrosion, and the baking soda neutralizes the acid. We rinse it, we dry it, and now it doesn't have any acid on it. It doesn't have any alkaline on it either, but we got rid of all the acid. Now we can put a coating on it and put it back together again. So the baking soda is there to neutralize the acid that's on the outside of the battery. Did I answer your question okay? If you want a discussion about pH numbers and stuff, see me after class. So distilled and demineralized water. The inside of that battery, and I looked at the previous slides, there's those lead plates and there's water and sulfuric acid in there. But if you put in water that has calcium, calcium's pretty common in a lot of water systems, or anything else, if you put the calcium in there, whatever's in the water will stick to the plates inside the battery, and that little spot where the calcium is, that part of the battery doesn't work anymore. So you put enough dirt or sand or anything else in there, then the battery works less and less and less and less. So when you're putting water into the battery, you only put in pure water. Don't put in drinking water, because drinking water usually has minerals like calcium. So you need to put in distilled water or demineralized water, even in your car battery. Now, Mr. Johnson, if the level is too low and I'm just pouring in water, about the acid, don't I need to pour some acid in there? Because, like, I know Fred down the street, he doesn't look very good, but he keeps asking me if I want to buy some acid. I keep telling, and I keep telling him, no, I don't need any acid. I only put demineralized water in my batteries. So thank you. I got a couple of chuckles there. The acid doesn't evaporate. That's right. What's happening is, inside the battery, if it gets warm, some of the water, H2O, might evaporate. Also, the chemical reaction inside the battery, which I'm not going to go into, I think it was on previous slides, and I'm an aircraft mechanic. All I need to know is what I need to know. When that battery charges and discharges, when it charges, part oxygen comes out and hydrogen comes out. It's because some of the water is being broken apart into oxygen and hydrogen. So when that happens, the oxygen and hydrogen leave, and the level of the battery goes down. But the only thing that came out was water. So if you get a brand new battery, and you fill it up correctly with the right amount of water and acid that comes with the battery, the acid doesn't come out. Unless you turn the battery upside down and fill it. Other than that, you're only going to put in water because it's only hydrogen and oxygen or water vapor that comes out, so you only have to put water in it. Oh yeah, yeah, I'm gonna go home and tell all my friends I know about lead acid battery. And you're gonna go like, yeah, that guy down the street that keeps asking us if we want to buy some acid, we can tell him no this time, instead of yes, like last time. I think there's a picture on the next slide. Oh wait, we gotta watch the YouTube video, don't we? Okay, it doesn't want me to let me watch the YouTube. Oh, I see why. I gotta turn it back to an arrow. So there's two big little airplane battery manufacturers. Concorde, this is...
Can't store.
Here, we'll go back.
Holder with Concorde battery. Thanks for taking some time to talk with us.
There's Concorde and there's Gill, but they're all lead acid battery, so what applies to one applies to the other. And there's almost no difference between lead acid batteries in airplanes and lead acid batteries in cars. There's two main differences. You do not have to write these down. Airplane batteries are usually a little smaller, and the concentration of acid is usually a little bit higher than in car batteries. The concentration of acid is higher in car batteries. I mean airplane batteries. Airplane batteries. Oh wait, I thought the third one. Airplane batteries are 3 to 10 times more expensive. So I got a 1969 172K. It's got a 12-volt battery. It's about this big. And it's like a really big motorcycle battery or a really, really, really small car battery. Even though the engine is a 320 cubic inch Lycoming, the battery's only about this big. It's $274 for a new one. Where that's probably about a $50 or a $70 car battery. So what's that? Is that like 4 times more expensive?
On air at TV today here at Oshkosh. Very happy to be here.
Pleasure to be with you guys today.
Let's talk about some of the things about batteries, because people really, it's one of those things that they take it, they put it in their airplane and kind of think, well, okay, I've got a battery. But there are some common misconceptions. What are some of those?
Well, there are a few out there. Probably one of the older ones is that you can't store lead acid or NiCad batteries together or service them in the same room. In the 60s and 70s, technicians used to service NiCads and lead acids out of the same pail of water with the same syringe. And you have an acid electrolyte and an alkaline electrolyte, and they would contaminate the batteries through that same pail of water. Nowadays, Concorde constructs valve-regulated lead-acid batteries that are sealed. Now, these valves are designed to allow the battery to exhale and not inhale. Now, in addition to that, we have added a flame arrestor to our vents, which will not allow a flame to be ingested into the battery, which could possibly obviously cause an explosion. So nowadays, with them being sealed, you can store and service these batteries in the same room.
A lot of people think that the battery is just to make the airplane start, but there's a lot more to it than that.
Well, there is. A lot of people think that their battery is just for starting their engine. And I'll divide that into two segments. In the certified world, that's half the truth. The other half is that they are needed for essential power. If you lose your generating system at altitude, you're in IFR conditions. In the LSA world, there's a little bit of pushback. Hey, we're flying on the weekends at 1,000, 2,000 feet in nice weather. We really don't concern ourselves with IFR conditions. And what I would suggest to them is that an aircraft battery provides essential power, it provides reliable power, and it provides longevity of life. Now, an LSA is still an aircraft. An experimental aircraft is still an aircraft. So, like a certified aircraft, 99.9% of the issue out there, they need it as well. So that's something that we would ask the light sport guys, the experimental guys, to consider when they're out looking for a battery and to get a certified aircraft battery as opposed to, say, a motorcycle battery.
Now, just because the airplane starts doesn't necessarily mean you have a healthy battery.
Well, that's absolutely right. You can actually have a battery that shows a full charge, a 12-volt battery of 12.9 volts or 25.8 volts and a 24-volt battery. But that battery could be so badly sulfated that, yes, you would have enough power to start the engine, but you get to altitude, lose your generating system, you might have 10 minutes, you might have no minutes of essential power, and then it becomes a life and death issue.
What about taking it out, just sitting on the concrete, you're not going to use your airplane for a while?
The oldest myth in the book that our grandfathers taught our dads and our dads taught us is, son, don't store your lead-acid batteries on the concrete floor in the garage because the concrete will suck the energy right out of the battery. It doesn't matter if they're hanging from the ceiling, sitting on the shelf, or sitting in your aircraft out on the ramp. All lead-acid batteries bleed off energy. Now, sealed lead-acid batteries bleed off energy 3 times slower than the old flooded batteries, which we stopped making about a year ago. So the point is, wherever they are, they're going to bleed off energy. If it's hot, it's going to happen faster. If it's cold, it's going to happen slower. But it's important to maintain those batteries and keep them fully charged. That is the secret to making lead-acid batteries last.
That was thrilling, man. I was enthralled. Has anybody ever been enthralled? Okay, one person has been enthralled. Have you ever seen that Star Trek original TV series with the Thralls? Okay, all right. If you're not familiar with that TV episode, see me after class and we'll talk Star Trek Thralls. Do you have a question, Alantino, that applies to batteries? Go ahead. Charging by what? No, you cannot charge a battery by making it hotter or colder. The only thing you're going to do if the battery is hotter or colder is allow the chemical reactions to go faster. Generally speaking, a lead-acid battery, and we've only been talking about lead-acid batteries today. There's also nickel-cadmium batteries that we're probably going to get to tomorrow, and there's some other lithium-ion batteries that we're going to talk about. But lead-acid batteries, which are in the majority of small airplanes and small helicopters, effectively, and I'm going to get to your question, if it has a piston engine in it that burns gasoline or diesel, a piston engine, and it's almost always has a lead really well for starting the you don't have to write this part down, but if it's got a turbine engine in it, it almost always has a nickel-cadmium battery, and when we get to nickel-cadmium batteries, we'll talk about why. But back to lead-acid batteries versus warm versus cold. You got to understand inside the battery, chemical reactions occur when you charge it, and chemical reactions are occurring in the opposite direction when you discharge it. If it's warmer, chemical reactions can occur faster. So if the battery's warmer, you can suck more energy out of it faster. If it's colder, you can't get as much power out of it as fast. So you take two batteries, brand new, they're fully charged, you put one in a car and you let it sit in Death Valley in the daytime, and under the hood it's 120 degrees. How much power you can get out of it is more than if we took an identical battery and took it to Alaska in the winter and it was minus 30 Fahrenheit, and we tried to start up the same car, we tried to suck as much energy out of it. For a lead acid battery, the colder it is, the less energy you can get out of it fast. Now, they don't use this. Did I answer your question? In the last 2 minutes here, I want to talk about cold cranking amps in cars. How many people in here are going to airplane mechanic school and think that a couple of things you'll learn in aircraft mechanic school, you'll be able to apply to cars and you'll be able to save people on the side of the road and be a hero and be on TV? Okay, only 2 or 3 of us. All right. Well, for you, this is important. Cold cranking amps, or CCA, you'll find that on car batteries, and that's to tell you, oh, we put this battery in a cold temperature, and then here's how many amps we could get out of it when we were cranking a motor, cranking an engine. So, for instance, if you look at the battery and it says 500 CCA, 500 cold cranking amps, they're saying under a certain set of conditions, it's cold, they could allow 500 amps to come out of the battery and go to the starter motor. That's a lot of amps. You might look at another battery and it says 800 CCA, 800 cold cranking amps. That means that you could, more amps could come out of it and therefore start a bigger starter motor, which could start a bigger engine. So if you've got a 1975 Honda Civic, the battery may only have 300 cold cranking amps, but the starter motor on this little 1.5 liter engine doesn't need that much power, doesn't need very many amps. But if you have a big old giant diesel engine truck, you need a starter motor that puts out 3 times the power just to spin around the engine. You don't need 300 cold cranking amps, you might need 900. But this cold cranking amps is only in cars, and it's only talking about how much power can you get out of it during start. If you're concerned that I marked you absent and you're not sure when I marked you absent, you need to come see me now. And if you're in, come see me now. Class is dismissed. Yes, to answer your question, I called your name twice and you did not answer and your seat was empty. So I marked you absent. So let's see, you came to see me at 45 after. Do you have any other questions?
I didn't want to bother you. You seem so angry.
Next time I highly recommend when you come in late that you tell the instructor immediately. So they won't mark you, because the way I take roll is the first moment I see you is when you start getting credit. Do you have any other questions? Can I help you? And your name is? Oh, I'm trying to see where you sat. There's no one behind you, William. Oh, Daviel, sorry, I thought you said Daniel. Yeah, so I see you now. Hi.
Ashton came in late.
And I first saw you right now. I didn't call on you in class, did I? Yeah, well, let me rephrase that. After I took roll, did I call on you in class? Yeah, I highly recommend if you come in late, you need to tell the instructor the moment you come in late. But that's just a recommendation, because I'm not your normal instructor. Hi. Luis. You heard all these conversations here, right? I see you now at 8:56.